Welcome to Unit Testing is Dead. Long live unit testing. Come have a seat. Everybody listening up. This is a guy over there with a squid on his head. I'm a little worried about him. We'll check on him later. This is an interactive presentation. I may ask you questions. I get to see your lovely responses. So let's try a dry run here. If you were a Dreamforce and you know it, raise your hand. Oh, we have some people in trouble here. Coffee is over there, I believe. All right. I work for Salesforce. My name's Kevin Porman. I'm a customer success architect. I like Twitter. At the very bottom of this slide, you'll find my Twitter name. You can harass me there during the talk. I will feel ashamed or laugh afterwards, I promise. But because I work for Salesforce, we get to look at this slide. If you've seen this slide before, raise your hand. We've got people who've been to, this is not their first presentation of Dreamforce this year. This is a forward-looking statement slide. It says, I work for Salesforce. I may accidentally say something that is not yet released or in the future. You should always make your purchasing decisions based only on what is publicly available right now. Everybody got that? There will be a test later. Let's talk about what we're going to do here. We got a little bit about why we're here. We're going to talk about why developers hate writing unit tests. If you've written a unit test, raise your hand. Some people are still confused. Okay, if you've hated writing a unit test, raise your other hand. Ah, I tricked you up on that one. All right, we're going to talk about why developers should write unit tests. We're going to pause for a second and deal with what is a unit test. We're going to see some patterns for writing useful unit tests, and I'm going to emphasize the word useful. Not all unit tests are useful. And we're going to look at some example tests about how to actually do this. So let's start with this. Why do developers hate writing unit tests? Somebody give me a shout out and answer. They don't understand the value. This guy, have you seen this presentation before? All right, anybody else got one? Takes too much time. I've got a whole list of them here. You might be a unit test hater if you've ever asked yourself, your boss, your coworkers, your interviewer, the person you're interviewing for a job, if they provide a return on investment, if they are worth the time it takes to write them, if it's worth the brittleness that it brings to your code, if it's worth the repetition of writing a unit test with tidying up your test data and writing the assertion, if they're worth the boredom of writing unit tests, if it's worth the maintenance of writing unit tests, and the very biggest one is the question of whether or not they provide any quality. So if you've been a unit test hater, raise your hand. I know I have. I was in college, I was like, no, just no. All right? But it gets better. Guess what? Dear unit test haters, I have so much more for you to be upset about on the Force.com platform. Just be patient for this slide. You see, on the Force.com platform, we have a couple of things that most unit test systems don't have. We don't have mocks. You can't mock out a class or an object. We don't have stubs. Oh, I miss stubs. You can't run your unit tests locally. They have to run in the cloud. We are, after all, a cloud computing company. Now, a little bit about unit tests and their speed. They're slow. They're especially slow on the Force.com platform. Anybody have any idea why? Because we at Salesforce want to torture you. No. They're slow because they're queued on the system. They're run as resources are available, and then the results are returned to you asynchronously. Have you experienced this? Yes. Now, for real, I kid you not, unit tests on the Force.com platform can be very, very slow. So, what exactly is a unit test? I have a quiz here. This is the part where you get to yell back at me. So we're going to look at this bit of code here. This is a test function. Don't expect too much from it. What is the unit of code that we would test here? Anybody? Well, if you answered just one section of it, you're spot on. Who saw that coming? Again, this is the interactive portion. Raise your hand if you agree or, okay. So when we talk about a unit test, we're talking about not a method that we're testing. This isn't method testing. We're not talking about testing a feature. This isn't integration testing. And we're definitely not testing what everyone does and how they use the system. This isn't system testing or UI testing. This is unit testing, a very small bit of your code that we're going to look at. In this case, the unit here would be the else statement. So we would pass in code or make our test work in such a way that we would hit this else statement and tell Astro the bad news. Is there another unit here? Is there another unit we could test? Yes, if it's true, if Bob's our uncle, then we can move on and test that. So if we have this method here with a unit test, how many unit tests do we have at least? I'm giving the answer away, aren't I? Sorry. We have at least 2 unit tests here. Do you think there's more? But wait, there's more with only one easy payment of, no. Why do we write unit tests? We write unit tests specifically because we can only control our code. If you work on a large team or a group or an org that has multiple teams on it, anybody out there? Okay. How many times have you written a piece of code or refactored something and it broke somebody else's code? Yeah, I'm up to 74. I hope to get 75 by Christmas. It's in my V2 mom. All right? Now, we can only control the APIs and the code that we're writing. If we're interacting with stuff that is outside of our org, or interacting with code that is in our org but controlled by a different team, we have to write unit tests so that we catch when they change something. To do this, we isolate our code, and we write our own test data. We'll see more about that here in a little bit. So why do we write our unit tests? This is my favorite standard reason. These are the reasons you show up at the interview and they say, so why do you write unit tests? And you say, because management said so. No one's ever said that, right? Right? No one ever says this, but oftentimes people write unit tests because they're told you have to write unit tests. This is not a good reason for writing unit tests. There is no motivation for code quality, for return on investment, or for any of those other things we talked about being a hater for in this reason. Another one is, unit tests prove your code works. Who's heard this? Anybody? Nobody's heard that unit tests prove your code work. All right, we got 4 people. A lot of times, people will tell you that you write unit tests so that you have proof that your code works. Is that true? Kind of, sort of. It's true like an elephant joke. How do you put an elephant in the refrigerator? You open the door, you put the elephant in, you close the door, right? It's true on the very face value of it, but it's not necessarily useful, right? You can prove your code works by doing an integration test, or just by sitting there and clicking through the UI and testing things. That's not a great reason for writing unit tests either. And this is my favorite one, I think, perhaps. You write unit tests because the platform you're using makes you write unit tests. This is a freebie. Who's got to do that? Everybody on the Force.com platform has to write unit tests. Now, we don't do this because we're mean and we want to torture you. We do this because it helps improve the overall health of the system overall. You and you and you and you are all on the same hardware running on the same time. And we need to make sure that I'm not on there writing code that's not going to work and tear down everybody at the same time. So we make you write unit tests, but again, is this a good reason for writing unit tests? No. What do you get out of it? You get to deploy. That's about it. Now, what if unit testing isn't about proving something works, following your manager's orders, or making the Apex team not cry? I did a research study when I was in college on the cost of a custom system for computing, custom computing system. And I did a lot of research for it, and over the years, some of the people that I was interviewing and talking to have done further research, and they keep doing this every 4 or 5 years. And the latest one came out in 2014, and they discovered that in 2014, the average lifespan of a software project was about 12 years. 12 years. The average lifespan of a developer at a corporation is 27 months. Let's put that in perspective. Now, over the course of that 12 years, only about 3 or 4 years are spent actually developing the system. The rest of them are in maintenance. So with that in mind, our unit tests aren't necessarily for us when we're developing our code, but for those of us who are following after, who are trying to maintain our code. Those murderous psychopaths we know the company we just left is going to hire to replace us. Also, they're giving out our address, right? Well, what do we do? Why do we do this? It's the long view. We're writing our unit tests now, as we're developing, for the long view, for the maintenance period that comes after our development is over. This is the biggest reason we write unit tests. There are specific things that come with that. The first one I want to point out is that this provides documentation. If you've ever written a unit test and then had to go back and refactor a class long after you forgot how it works or even necessarily what it does, Having a unit test there shows you what portion of your code you're working with, how you get there with your input data, and what that does in return. So you have a documentation of sorts that lets you follow what is going on in your code base. Also, when somebody follows after you, they can do git blame on your source code, and then they know who to ring up via email or Twitter, etc., and be like, when you wrote this, what do you mean? If you've got unit tests, you can go say, hey, go look at the unit tests. I documented that for you. How do we actually ensure this in our unit tests? How do we make sure that our unit tests provide that level of documentation? Well, we liberally use asserts. I like to talk about using asserts the same way that some people talk about Chicago politics. I want you to assert early and often, right? All right. Lively crowd today. We're going to isolate our code that we're testing, our unit, in the start test and stop test functions. We'll see how that works here in a little bit. We're going to test not only positive scenarios, but negative scenarios. What are positive and negative scenarios? A positive scenario is given valid input data. When the unit is called, I get a valid result at the end. So if I call an add method with 2 plus 2 and it's a positive unit test, what do I expect in the response? 4. Negative response. If I pass in invalid data, what do I expect to get back? What kind of assertion, what kind of exceptions should I expect in return? So in this case, when we're doing a negative test, we might say if we're going to do a divide test and we pass a 0 in as the denominator, what should happen? We should get an exception. We're going to test for that exception so that we know that we're properly capturing them. And we're also going to write comments in our test. Who's commented test code? Who comments the regular code? Some of you were lying. All right. Unit tests accelerate the maintenance or change in general. So you write a piece of code. It is for taxes for the state of Washington for 2016. When are you going to have to update that? 2017, the next tax season. How are those rules going to change? You don't know yet. But you're going to have to change how you're calculating the taxes. So going in and changing your method will also let you, by running the test, know if you've broken anything that method uses. It allows you specifically to change a method's implementation and know if you've broken anything else in the system. It's incredibly valuable, but it's more valuable in year 5 through 12. Because when you get a fix to come in or you get a maintenance request, how much time do you get to do that in relation to actually writing new code? If it's any place where if your workplace is anything like mine, we get a little bit of time to do maintenance requests, and most of our time is dedicated to writing our new system. So these unit tests really accelerate the speed at which we can turn around a maintenance request. They help fight scope creep. Who's done scope creep? Everybody's done scope creep. It'd be really nice if we just added this one little thing. But if we're spending time writing our unit tests, we're going to have less time for going, oh, I can add that one more thing in there. Does everyone see that? It's a pretty valuable one. At the end of the sprint, you can go to your Scrum Master, you can go to your product owner and say, look, I delivered everything you asked, and not this one thing that you should have asked for. How do we do this? We write our unit tests for every single unit in our feature. This is the hard part, getting that code coverage up there, testing every bit. Most people do not work on a team of one. If you have other team members, having unit tests makes sure that you're not stomping on one another. Can anybody come up with a good example of that in their history? Anybody? Okay. Now, when I was working on a team, I would write some classes, I would save it, and then inevitably, my coworker would write a method that did the exact same thing. Best practice, don't repeat yourself. I'm going to delete my method. Now, thankfully, my coworker wouldn't go delete his method. I'd just rely on his. But now I need to swap out my call to my method to his call and his method. But the unit tests shouldn't change. If they're truly identical methods, if they're doing the same behavior, then all I have to do is swap out that call and I'll know whether or not I can move on. They accelerate the ability to change your code when working with multiple people in the same org. How do we do this? The first one is you have to write meaningful unit tests. Not every unit test is meaningful. We're going to talk about how do you write a meaningful test, but you have to write meaningful tests. You're going to have to liberally use asserts, and you're going to have to frequently run your tests. So you're going to have to want to write them quickly and to make them to run fast. Unit tests also protect us against platform changes. Who remembers the switch from script statements to CPU governors about 3 or 4 releases ago? Who got bit by that? Unit tests help us know these things because if you run them in a pre-release org, you'll catch, oh, my code is no longer performant the way it needs to be for this governor. I don't read all the release notes, and I don't know if you do, but that's an epic novel 3 times a year. And by not reading those notes, I'm leaving myself and my company vulnerable to code that is no longer going to run. It's going to throw exceptions. Unit tests hedge against that. My favorite one, though, is that unit tests provide enhanced software quality. And I know I've had 3 favorites here. Bear with me. Now, in order to unit test your code, one of the things you have to do is be able to break it down into its various units. When you break it down into its various units, you start to learn something about your code. You start to learn exactly how that code works from a logical standpoint. Because I'm betting that most of you, like myself, don't sit there and think, oh, I'm just going to do an if block, but wait, if I do this if block here, then I've got to go and test this here. And no, you write an if block to make a quick decision and you move on with life. And as you go write your unit tests, you're going to start to pick up on discrepancies in your logic. Because we tend to move quickly in writing code and slower in writing tests. So by writing those tests, we're slowing ourselves down in the writing portion, and we'll actually be able to catch a lot of logic bugs as we understand exactly what our code is doing. How do we do this? We intentionally write very, very small unit tests for very, very small units of code. And we test everything that we can. There's some other reasons to write unit tests. The first one's going to be a bit controversial. I like to write unit tests because they're fun. Now, what do I mean by fun? If you read through my unit tests, you're going to find a lot of references to Doctor Who, his companions. You're going to see the Avengers in there. And my unit tests tend to be an epic battle between the Avengers and the villains, where the Avengers are winning and the villains have no access to the data because they're locked out by permissions. That can be fun, right? You don't have to be an Avengers fan. Maybe you're like, I'm Batman. If you're Batman, Batman can be the winner, and the Joker can be the guy who has no access to your data. It also reduces anxiety. If you get into the practice of writing tests, you're going to feel more comfortable doing your job because you know that I can go test this. I'm going to prove it if only to myself. And as part of doing that, I'm going to reduce my anxiety level. Is writing tests to prove your code works a good idea? Not necessarily. But writing tests to reduce your anxiety level with changing your code base has immediate and powerful rewards. So the rule of unit tests is this. A unit test is only as good as the assertions you write. Let's repeat that. A unit test is only as good as the assertions you write. If a unit test has no assertions, what do we call that? A waste of time. What does HR call that? Time theft. No. If there's no asserts in your code, in your test, it's not really doing you any good. You're not going to get any of the benefits we talked about, except for maybe having fun writing them. In which case, I don't know why you'd write them. All right? You have to write asserts. What are the 3 assert methods? We have system.assert, which accepts a Boolean expression for evaluation. We have asserts equals, takes 2 values that are asserting them to be equal, and we have assert not equal, which says these 2 values should not be equal. We also have optional third parameters on all those methods that take a friendly message. That friendly message says, hey, future developer who's murderous, a psychopath, and knows where I live, you should look at this line of code in this test because this is where it failed, and this is what I expected, and this is what I actually got. You should use that friendly message, even if it's not so friendly. So we're going to look at some patterns for unit testing. We're going to start with positive unit testing. First thing you do is you identify the unit of code to test. This is paperwork. It's not exciting. You're going to say, okay, I've got a method. It's got 15 branch logics. I've got at least 30 tests. Here we go. Start writing out what those tests are. Next thing you're going to do is you're going to create your own test data. Why do you create your own test data? You create your own test data because you can never guarantee what's going to be in the database at any given time. Always create your own test data. If there's a second rule to unit tests after you have to use asserts, it's use your own test data. Third, you're going to assert that your data has been created. Why are you going to assert your data has been created? Because somebody may have gone in and created a new validation rule or workflow rule, a process. Another team may have written a trigger and suddenly your inserts didn't work. You want to know about that before madly getting failures because your data wasn't there or wasn't what you expected it to be. So assert that your data is not only there, but it hasn't been modified by somebody else. Then you're going to call Then you're going to call test.startTest. This isolates your unit of code from all of your setup methods, all of your DML, all of your governor limits that have gone before, so that you get good and accurate profiling and information about the unit you're testing. Then you're going to execute the unit of code that is your test data, with your test data, right? You're going to call your method, you're going to pass in that good data. You're going to call test.stop-test. What's on the screen, not what I'm fumbling over. And then finally, you're going to make some assertions that given valid data going through your unit of code, you got valid results. This is the most basic unit test pattern. Everyone make sense, everybody? Some nods? Yeah, okay. Now we're going to get a little more complicated. We're going to insert users into the mix. Now, if we create our own test data and we're using asserts, we're also going to have to create our own test users and assign them profiles and permission sets to set them up how we want them. So in a positive user test or a positive permission test, we're not only creating test data, but test users, and we're assigning them permission sets. So the thing we're going to do is we're going to identify our unit of code. That should be familiar. We're going to create a user. This is our new step with the proper permissions, with correct permissions. We're going to create our test data. That's familiar. We're going to assert that our data has been created, including our user. Check their profile. We're going to call system.runAs. We're going to call test.startTest. Now, I passed over that system.runAs. That lets us run a bit of code as the user. We're going to pass in that user we created to run as. So we're running it as Iron Man. Iron Man should have the proper permissions, so when we call start test and execute our code, when we finish doing stop test and we get back to asserting that our values are correct, we should see that Iron Man had access to that data or was able to run that method. Does that make sense? Okay, that's a little bit more complicated. Now we're going to switch over to negative unit testing, which is even more interesting and fun and complicated. So the first thing we're going to do is identify the unit of code to test. There are multiple units of code in every method. We're now going to create our own invalid test data. It's invalid test data. We're intentionally going to be passing in bad data because we want to catch a specific assert. So if you have, a specific exception. So if you have a bit of code that can catch 4 or 5 different exceptions, how many negative unit tests are you going to have? 5. We're going to assert that our data has been created. That should be familiar. We're going to call start test again. We're going to execute our code. We're going to start a try block. Those two are reversed. We're going to start a try block and call our code. And we're going to assert that the method functioned and created us an exception that we can catch. We're going to catch only a specific exception. And inside there, we're going to set a Boolean to true. We did catch the proper exception. And finally, we're going to assert that we caught that exception. Forgive my little slide snafu there. I'll show you what this looks like in our actual code in a second. And we're going to assert everything based off that Boolean. Does that make sense? This can be a little complicated. It may make more sense when we see the actual code. Negative permission user tests. Guess what we're going to add in here? We have a negative test we're going to add in users with the appropriate permissions or wrong permissions as it could be. We're going to identify our code, create test data, invalid test data. We're going to assert that the data has been created. We're going to run this code as our user. We're going to start the test. We're going to execute the code. Again, that's backwards. We're going to catch that in our try catch block. We're going to catch just that one exception. And finally, we're going to assert everything. So I'm going to jump over to the code. 1 second here. There we go. So to do this, I made an example code class. It's pretty exciting. We've got an add method. We've got a divide method. We've got a get bank account method. That one's particularly exciting. and we've got a bank account method that'll throw an exception rather than fatally crashing. There's nothing too excited in here except that we are checking for a divide by zero error in our divide method. And we've got this one that'll throw a particular type of exception. And we're going to switch over to the tests here. Now, I put this test up on linked on Bitly, so you can see it. I'll put the link back up here in a second. But I went through and I documented this so you could put it in your org and play around with it and test it. It does require some prerequisites. You're going to have to create a field on an account, that sort of thing. Nothing terribly exciting. But then we can move right on into our example tests. So this first one, example to add positive, is a positive test class. I like to name my test methods exactly what they do. So I'm testing the add, and it's going to be a positive test. Does that make sense? Right? That's useful when it fails. I can see in the failure, test add positive failed. I know I've got something going on with either my data or the actual logic of the addition method. It's not necessarily a divide by zero error, for instance. Now, in this case, I'm going to create an instance of my example code class. And you'll notice that I'm calling start test. And then I'm actually calling that method. And then I'm calling stop test. Now, by calling the start and stop, I'm isolating my code. We talked about why that's important earlier. And when I run that method with 5 and 7, because this is a positive test case with valid data, what should I expect when I get back? Math is hard for me too. I should get 12 back. Right? And see, down here at the bottom, I have an assert equals 12. And I'm saying why with that friendly message. 5 and 7 should be 12. That's the most basic unit test we've got. Does that make sense to everybody? I'm going to wait till I have nods from everybody before moving on to the next one. Okay? Here's a division positive test case. It's just like the last one in its logic flow. I'm passing in a division with 1 and 1. 1 divided by 1 is 1. So I've got an assertion here. You'll notice the only thing that's different is I've got 1.0 because it's a decimal, actually. No big deal, right? Make sense? Now, if we scroll down a little bit further, we've got a divide negative test. And this one's a little bit more exciting. In our try-catch block, we're going to make that divide call. We're going to divide 1 by 0, which is not everyone at once. Divide by 0 error. When we get a divide by 0 error, the system will automatically throw an exception and we're going to catch it. We're going to catch an example code exception, awesome exception. We're going to pass that back. We're going to have a Boolean value, did catch proper exception. We're going to mark it to true. And at the very end of our test, we're going to say that the system assertion that we have is that we did catch proper exception. We're going to set that, we expect that to happen. We're going to leave ourselves a friendly message. Questions on negative test pattern? I can't hear you. For all I know, you just asked me about lambdas in Apex. I have no idea. Now, if we scroll down here a little bit further, we've got a positive test case for having access by profile to a particular feature or field. In this case, we're going to create a user with a standard user profile. We're going to create a super secret bank account on an account. We'll save that. And then we're going to run and call our method getBankAccount. And because this is a positive test method, we're expecting that to result in what we set it to above. Pretty basic. The only addition is this runAs method with our new user that we've created. Questions on that one? I still don't know about lambdas. All right, one last one. A negative profile test. This user profile has no access to get the bank account. Bank account's a protected field. I'm going to say that the chatter-free user doesn't have access. When I run as, I should get back nothing because it's an encrypted field, for instance. And we're going to say that the Sith Lords should be blocked. They shouldn't have access. Questions on negative user tests or negative profile tests? All right, so with that said, I'm going to go right back to this, maybe. There we go. And I told you I'd put that bit.ly link back up here. The bit.ly link is to bit.ly/example tests. That'll give you the example code class and the example tests. And if there are any questions, I'd be happy to answer them. If you don't ask me questions, I will again start asking you questions like, what are your plans for dinner tonight? All right? Questions, comments, Snyder marks? Yes. A mixed DML error. That's going to take longer than I have. We'll talk in just a second. Preference. Actually, to be honest with you, I use IntelliJ as my editor, and I've used it more often, and so it fills that in for me automatically. Other questions? In the back. I can't actually hear you, but hit me. I'm sorry, what? This is really boring? I'm so sorry about that. I know, especially this guy right here. I really can't hear him, so I'm going to go on the idea that he's talking about the wonderful slides and all the little visual jokes that are in them. And I've tried to do that to make it more interesting for everyone. If you've found that interesting, could we please drown out that poor gentleman, Asif Mandi, I think his name is, with laughter and clapping? There we go. All right. All right. Thank you very much.
Minor profiles don't last nearly as long as code, so then your tests have to be updated when you change your profile system?
Yep. So she just said her tests, her profiles don't live as long as the code does. So if you update profiles, you're going to have to update your tests. That's true. What I like to do is have a map or a custom setting. Excuse me, I've got a little, it's a little warm up here. I take a custom setting and I put a profile name for testing and a profile ID. And that way I can change those just in the custom setting, and my tests will use those for my testing. Does that make sense?